Okay, we're going to find the volume of my favorite Weeble Wobble here. I don't know if any of you had these as a kid. I did. Anyway, they're awesome. They weeble and they wobble, but they won't fall down. Anyway, so this guy right here, we're going to find the volume, and it's kind of this egg-shaped thing, and I did a little Googling, and I did a little research, and I found this equation. Of course, the square root of, and then in the numerator, 1 minus 0.5x squared divided by 1.96 to the x. I messed with it a little bit to fit it roughly to this. Okay, this is not something we'll be able to do without a calculator, and that's what this is all about. So I've graphed this equation in my calculator, and of course the calculator having low screen resolution, it doesn't do it very well. Like that should actually be going down to the x-axis on both sides. And that intersection point, by the way, on both sides is the square root of 2. So when x is root 2, I have y equals 0, and you can see that, yeah, I am on the x-axis here, and pretend that it's actually drawn so that it reaches all the way down there. So I have this as my y1. When you're putting it into your y equals, remember that your numerator inside that radical does need to be in parentheses. There's no chances at all to mess things up, is there? Okay, so looking at this guy, if I draw in my sample rectangle again, and then I draw in this shape, or just what I get from one slice, I just get that kind of coin shape. So it's just a pi r squared h, where my r is y, pi is pi, and h is dx. And my bounds, this is negative root 2 to root 2. And I can do this on my calculator, so that's kind of handy because this isn't something, even after I've squared it, I can't integrate this. So what I'll do is just on my home screen, that math 9 that we've done a million times, negative square root 2, positive square root 2 are my bounds, and then I can put my pi in, so second exponent, and then my y1, alpha trace 1, and then my x, I hit enter, and it thinks about it for a while, because it's basically doing Riemann sums underneath the hood of sorts. So it does take a little while to do this. Why isn't this doing this? It's so slow. Goodness me. So eventually it's going to give me an answer. Can't believe how slow it is. There we go. 7.178. Here's the crazy thing. Like on a test, if it's a calculator question, this is literally all that needs to be written, as long as you also have your y. That's enough. That's all you need. Kind of crazy. By the way, you can also take the pi out, and this is going to take a while to run, but then whenever I'll get some decimal answer, and then I can write that decimal with a pi at the end. So eventually it'll tell me that number. So it's okay to do it that way. The only risk in that is that you risk forgetting it. So, but this answer is also, you could write it as 2.284 ... pi. So that's totally fine as well. Your call. The only risk about doing it that way is, of course, forgetting the pi. Or I could have hit times pi and hit the enter and then gotten that same decimal again. So there it is on our calculator. It's going to be pretty handy. So eventually you're going to do it. I mean, a lot of these problems you're going to do this way. I will tell you that. So that way you can get on with it and not be bogged down with all the mechanics.